Welcome class. You should be watching this video on Tuesday, September 1st. This is for my algebra students. Today we are starting a new unit on functions, and so the first thing we want to talk about is what is a relation and what is a function. That is basically going to be today's content, is what makes something a relation versus what makes it a function. A relation is a set of ordered pairs between two variables. Some relations are called functions, specifically when each input value only leads to one specific output value. I'm going to step away and give you guys an opportunity now to copy this into your notes. Of course, you could just press pause on the YouTube video, so just go ahead and do that if you need it. All right, so when we say it's a set of ordered pairs, that means we have points like 2, 7, 3, 8, 5, 9. So we have 3 points. These 3 points in this specific case make a relation as well as a function. In fact, anytime we have a set of ordered pairs, it is definitely a relation, okay? No matter what combination of numbers we use. However, in order for it to be a function, what needs to happen is each of our x values can only lead to one specific y value, meaning 2, now that we've declared it goes to 7, can only lead to an output value of 7. 3, now that we've declared it leads to a result of 8, it can only lead to an output value of 8. And 5, this input value, since we're saying here 5 yields an output value of 9, the only output 5 could ever have for this function would be 9. In fact, if I added in a new point, if it's a different x value, like 11, it could lead to any y value we want it to lead to. It could lead to 200, and this is still a relation, because this is a new x value, meaning none of these x values are repeating to a new y value. This is a new x value, so it could go to 200, or it could go to 7, okay? That's right. Even though it goes to the same y value as this other point, that is allowed, because we are not going back in time and disagreeing with this statement. This statement says 2 leads to 7. Well, 11 can also lead to an output of 7. That is allowed. What we cannot have happen is we cannot introduce a new point and say 2 leads to an output of 3. This would be wrong, or this would make it a relation and no longer a function, because we already declared here 2 leads to an output of 7. So we cannot then declare and say 2 leads to an output of 3. No, that does not make sense, because we already said 2 leads to an output of 7. 2 does not lead to an output of 3. However, 11 can lead to an output of 7, okay? To put it in another way, let's assign x values. So let's say the x values are the student ID numbers. Okay, and we're going to make this really simple. We're going to say everyone's student ID is 1, 2, 3, 4, etc. 5. Right? So each number for x is a different student in the class. First person in the class, second person in the class, third person, fourth person, fifth person. And let's say that we let the y values let the y values represent, we'll say, quiz scores, okay? Here is my analogy for what makes something a relation versus a function, okay? First person in the class got a 78, second person in the class got an 85, third person in the class got a 60, fourth person in the class got 100, fifth person in the class got a 90. These are all allowed, okay? Not only is this a relationship, right? A relation is a relationship between two variables. It pairs them together. We have student in the class and quiz scores, so that makes sense, okay? not only is this allowed, in this case, this is a functioning system, right? This functions. It is a function. It makes sense logically. Each person has their own output that they're getting. The first person scored a 78. Now here is what I meant on the last slide when I said we can repeat a y value, we cannot repeat an x value. What if the sixth person in the class is also a genius and they score a 100? Is that possible? Yes. This is my analogy for why we can repeat repeat y values but not repeat x values. We are allowed to say that two people in the class, the fourth person in the class and the sixth person in the class, both scored 100. That makes sense, okay? That is still a functioning system. It makes sense that the fourth person and the sixth person in the class can both score the same result on a quiz, okay? What would not make sense, so this is still a function, we can have y values repeat. What does not make sense is to say the fourth person scored a 95 on the test. That doesn't make sense for a quiz. We already said the fourth person scored 100. How could they actually also simultaneously score 95? This is not a functioning relationship between student and test scores or quiz scores, because this one student, we are already declaring what they scored. We cannot say that that person actually scored something differently, okay? That would, what's the word I'm looking for? I'm not an English teacher. That would go against what we'd already said, okay? However, we are allowed to repeat and say the fourth person got 100. Now, this doesn't make sense necessarily from a logical standpoint of why would we repeat that same point, but it doesn't change the fact that it still creates a true system or a functioning system, so it is a function still, right? Maybe the teacher is saying, student 1, you got a 78, student 2, you got an 85, student 3, you got a 60, student 4, you got a 100, student 5, you got a 90. And then the teacher realizes student 4 wasn't paying attention, so they repeat themselves and they say, student 4, you got 100. It's still a true system because they haven't changed and said student 4 actually got something different, okay? So that's one of my analogies and examples for what makes it a function. Let me show you this now also in a table. So we can also look at what makes it a function or not in a table. So let's say we have 1, 2, 3, 4, and 5, and we're going to stick with x being the student number in the class. So first student, second, third, fourth, fifth, and we're going to say that y is their height, okay? 6 foot tall, 5'8", 6'1", 5'3", and we'll say 6 foot tall. So y is their height, x is the student number. This still makes sense. First person is 6 feet tall, second person is a new height, third person is a new height, fourth person is a new height, fifth person also 6 feet tall. Yes, that is still a function. I'm writing on the board just in case you have me muted because you don't like hearing my voice. My fault, sorry. Yes, that is still a function. Two people can have the same output height. That is allowed. Two people can have the same height. Totally allowed. Okay. Watch this. Ooh. Screen is acting up a little bit. Watch this. What if I repeat myself now and I say first person is 5'11". Okay. Now all of a sudden, we say, no, not a function. We cannot sit there and say the first person is 6 feet tall. Oh wait, now that same person is actually 5'11" at the same moment in time. That can't be possible. I cannot be two heights at the same time. Okay? That does not work. The other way that you've looked at what makes something a function or not in the past was looking at the vertical line test. So there's a rule that, let's say we have a function, and that function goes forever. As long as it passes what's called the vertical line test, then it is a function. Let's talk about what that means. If you were to take a vertical line and you were to run it across the entire function, so the function is this curve, okay, it would only ever cross at most one point. It could cross nowhere, but it at most would only ever cross at one point. Because if it crossed at a second point, so this is a function because it only ever crosses at one point, okay? Let's talk about what it means if it doesn't cross at one point. What if it crosses at 2 points somewhere? Well, here it crosses at 2 points. The reason this is no longer a function is because whatever x value this is, we'll call it -2. What that means is we actually have two heights at that x location of -2. Maybe we have the height of 1, 2, 3, 4, and we also have the height of 4. That's what this means when we're looking at the vertical line test. It means if you look at any location on x, right, each of these is a different location. Here's -2, -1, 0, 1, 2. Each of these is a different location for x. And what we're saying is there a moment when at some point on the x-axis, is there a location where an x value can lead to two different y values, two different heights on that function? Can it have two outputs? And this would make it not a function, okay? So that is today's lesson. I hope you enjoyed it.